Welcome to another edition of the Andromeda Time Slip. I'm Herc, along with Velocity and Laika.
Today we are at the Green Bank Radio Observatory in West Virginia. These radio telescopes are listening into outer space.
In this episode, we are going to tell you all about the beginnings of radio astronomy. Optical astronomy, looking at the night sky with our eyes, has been done for as long as man has been around. But radio astronomy is a new field when it comes to astronomy, less than 100 years old. Let's Explore Astronomy is sponsored in part by
Distinctly Yukon. The Westmark Whitehorse Hotel and Conference Center is the Yukon's premier lodging facility. Make your reservations today at westmarkhotels.com. Westmark Hotels, with 9 unique locations throughout Alaska and the Yukon.
Radio astronomy needed the invention of the telephone and radio first. Even then, radio astronomy was discovered by accident.
The father of radio astronomy is Carl Jansky. Carl Jansky worked for Bell Telephone Labs in New Jersey, starting in 1928. One day, Jansky was assigned the job of trying to figure out where static that interfered with transatlantic telephone service was coming from.
Let's pretend you are Carl Jansky, and I am a reporter in 1933. Excuse me, Mr. Jansky. I'm with the newspaper, and we heard that you discovered sounds coming from outer space. Can you tell my readers what this is all about?
Certainly, miss. I work for Bell Telephone, and we want to use short waves for telephone service between here and Europe. We're looking at using short waves of between 10 and 20 meters. Now, as you know, when you turn on your radio, there are a number of different stations. They are all on their own frequency. You turn the dial and the radio receives the frequency you want. Each frequency is a different wavelength, and the radio picks up just that wave you tune to. You're listening to AM 900, and now more music from the Starlight Ballroom. So, we want to do the same with the telephone. I have been investigating a frequency of 20.5 megahertz. This is higher than the frequencies used in AM radio, but lower than the frequencies in FM radio. The idea is to beam a phone call across the Atlantic on radio waves instead of by wire. But we must be sure that we do not have interference.
Okay, I get it now. So this is a really big giant antenna you built, sir?
Yes, tuned into 20.5 megahertz. It is on wheels that I made from a Model T Ford automobile, and it rotates so I can observe the entire sky.
So what have you found, sir?
Well, I have detected thunderstorms, both near and distant. And I have picked up a faint, steady hiss that I have no idea what is making it, but is coming from outer space.
Martians? You mean aliens?
No, it's not coming from a planet. And it is steady, not like a radio transmission. At first, I thought it was from the sun, because it seemed that was the direction it was coming from. But as the months went by, the center of the noise moved away from the sun. Its location did not repeat at exactly 24 hours, but instead at 23 hours and 56 minutes. This indicates it is coming from deep space.
Wow, signals from outer space. But who is sending them?
Not who, but what. They are coming from the center of the Milky Way galaxy itself, in the constellation Sagittarius. It will take more investigating and more refined equipment to figure it all out.
What is your next move?
I want to build a 100-foot diameter dish antenna. But as you know, this country is in the middle of a terrible depression and money is scarce. Bell Labs got the answer they need. The static is too faint to be of any concern to shortwave radio transmissions. So I will have to leave those answers to be solved by future scientists.
So Mr. Jansky went on to other projects at Bell, and other scientists took over the study of radio waves from outer space.
Jansky's original antenna was at Bell Labs in Homedale, New Jersey, but it no longer exists. A replica of Jansky's antenna is here at the Green Bank Radio Observatory in West Virginia. Today, Jansky is considered the father of radio astronomy, and it all happened by accident. This is Grote Reber. He tried to get a job with Jansky at Bell Labs, but because of the Depression, Bell was not hiring, so he set out on his own.
In 1937, Reber built his own radio telescope in his backyard near Chicago. Let's pretend that I'm that reporter again, and you are Grote Reber. Mr. Reber.
Yes? What may I do for you?
About 10 years ago, I interviewed Carl Jansky for an article in my newspaper. I would like to follow that up with what discoveries have taken place since then.
Okay, well, in 1937 I built this scope here in my backyard. It is made of metal and 31.4 feet in diameter. The cone is 20 feet above the dish. That is where the radio waves that bounce off the dish are focused. I also have a radio receiver that amplifies the signal by 1,000,000 times. Radio waves from space are very faint.
Your antenna looks a lot different from Mr. Jansky's antenna.
Mine is patterned after optical reflector telescopes. It is the same idea, but instead of reflecting light, this one reflects radio. By using this shape, I can use it over a wide range of wavelengths.
So what have you found out?
I started out at 3,300 megahertz and found nothing. I then tried 900 megahertz and found nothing. But when I dropped to 160 megahertz, I detected radio from space. It was coming from the center of the Milky Way.
That is the same thing that Jansky found.
Precisely. I was able to verify his findings. I then proceeded to study the whole sky and found that the highest areas of radio waves correspond to across the Milky Way, with the strongest waves at the center of the Milky Way in Sagittarius. I also detected strong signals in Cygnus and Cassiopeia.
So what causes these radio waves, sir?
Well, specifically, I cannot say at this moment. I found that radio power is weaker at higher frequencies. This is opposite from thermal or heat energy. So some non-thermal process must be the cause.
Stop the harp. I still don't have what causes those radio waves. If not aliens, then what? Go back.
Well, we actually have to move forward in time from there. About 10 years after that. In the 1950s, a Russian scientist, V.L. Ginzburg, came up with the theory of synchrotron radiation.
Say what?
Synchrotron radiation explains it all.
Oh, in what universe?
Ours. Synchrotron radiation is caused by electrons moving at speeds close to the speed of light in magnetic fields. Turns out, our galaxy is full of charged particles called cosmic rays. We think the cosmic rays come from supernova explosions blasted into interstellar space.
And supernovas can turn into black holes.
Yep. So radio astronomy can be used to study black holes also. This is the original telescope Reber built in his backyard. He donated it to be put on display here at Green Bank. From these beginnings, radio astronomy grew into a major science.
Radio astronomy is very fascinating. We don't have time to talk about it now, but a future episode will dive into the nuts and bolts of radio astronomy. We will tell you how it works and what incredible discoveries have been made and are being made by radio telescopes around the world.
Until then, here's to clear skies.
Happy stargazing!
Hey, give a shout out to our sponsors, without whom we would not be here. Visit their websites and partake of their services and products. A big thank you to the Yukon Department of Tourism and Culture and Westmark Hotels, Westmark Whitehorse.